Have you ever think about what type of current is flowing through these lines? Is it AC or DC? Yes, it is AC current. These are generating from AC power generators. So, what is AC current? Why AC current is represented in this kind of sine wave? Now I'm going to explain these AC currents in this video. So let's get into the topic. AC current means alternating current. It means the current always alternates here. To understand this, take an AC generator. The output of the AC generator is connected to a galvanometer like this. You know the galvanometer needle moves from left to right and right to left rapidly when AC current flows through it. Here the needle is deflecting because the current is alternating. Here a question arises that what is alternating? Alternating means current will flow in two directions rapidly. At first, the current flows in one direction so that needle goes to the left. Similarly, if currents flow in opposite direction, then it results in the needle to deflect towards the right as shown here. This has some cycles. One cycle means when the needle moves from center to right and from right to left and from left to center again. Consider an AC current of 0.3 milliamps, supplied to a galvanometer for 4 seconds, and it took 2 cycles. So the time taken for each cycle is 2 seconds. Now plot a graph between current and time. So, take the current on y-axis, and time on x-axis as shown here. Initially, we are not supplying any current, so the current is 0. And the time is also 0. So mark a point on the graph at 0 and 0 for current and time respectively. Now, imagine the current is supplied to a galvanometer. The needle starts deflecting to plus 0.3 milliamps, because we are supplying 0.3 milliamps AC current to it. Time taken for this is 0.5 seconds. So, mark a point at I equals plus 0.3, and t equals 0.5 in the graph. After this, the needle returns to 0 again. Because of the direction of flow of current alternates in AC current. So the current at this position is 0. Time taken is 0.5 seconds. But the total time is 1 second from the start. So, mark a point at I equals 0, and t equals 1 in the graph. Similarly, the needle will deflect to the left as shown here, up to minus 0.3 milliamps. Time taken for this is 0.5 seconds. The total time taken is 1.5 seconds from the start. So, mark a point at I equals minus 0.3 and t equals 1.5 in the graph. After this, the needle returns to 0 again. Here needle completed 1 complete cycle. You know the current here is 0 amps and the time taken for this is 0.5 seconds. The total time taken is 2 seconds. So, mark a point at I equals 0, and t equals 2 in the graph. Similarly, for the next cycle, the points will be like this as shown here. Now, join all these points. Then it will form a curve like this. It is representing a sine wave. This is what AC current is. This sine wave represents the behavior of the alternating current. Every sine wave has some number of cycles. From the graph, the positive side of the cycle is called as crest and the negative side of the cycle is called trough. When you are studying this topic, sometimes you will get the terms amplitude and angular frequency. So, what is amplitude and angular frequency here? Amplitude means, take a look at the graph, here the distance between 0 to the maximum point on crest or trough is called as amplitude. And, the angular frequency is denoted by omega, where omega equals to 2 into pi into f, where f is the frequency, which is given by the product of the number of cycles and total time taken. Thanks for watching.